Alright, so these are just some additional practice exercises based on exponential functions. So these are just solely intended for you to try and solve them on your own and see if the previous videos actually helped you to understand what these are, exponentials are. So it says the given graph represents the function f of x equals 2 times 5 to the x power. How will the appearance of the graph change if the a value in the function is decreased but remains greater than 0? Okay, so it sounds a little bit complicated. If we were to write that out here, f of x is equal to 2 times 5 to the x. All right. First, you kind of have to know is which one's the a value. Well, we know that this one, being this one, this would be the a, and this would be the b. Okay. Now, what does the a tell you on a graph? And if you still don't know what the a tells you, you should definitely go back to the first 2 or 3 videos and watch what it means or what kind of impact the a value has. Okay, so this tells you that when x is equal to 0, or like the initial amount, right, y is equal to 2. So this is where you're going to start off on the graph, and that's why on this graph, right, you see how it jumps from 0, jumps 10, so this would be 5. So this is actually starting at 2, right? It's kind of hard to see, but it is starting at 2. Now the question that they're asking is, now what happens if they kept everything exactly the same, but they chose a number that was less, that was decreased but greater than 0? So what's a number that's greater than 0 but less than this? A 1. So if this is a 1, what does this tell you then about the graph, right? This one told you that it started at 0, 2. So then this one would tell you that it started at 0, 1. So it'd be kind of the same exact graph, just a little bit lower. Literally the same thing, just move down a little bit lower. Okay, so would the graph increase at a slower rate? Well, what tells you what's increasing at a slow rate? This is solely dependent on our b value. That's the 5. Okay, the graph will show a decreasing rather than increasing. It will have absolutely no effect on how the graph is going to look like. So this is definitely not true. The graph will show an initial value, that's what the a is, that is lower on the y-axis. Lower just means it's just been moved down a little bit, right? So if this is 2, then 1 would be here. It would just be moved down by 1. So this is definitely true. And then the graph will increase at a constant additive rate rather than a multiplicative rate. Additive is only for what kind of function? A linear function. This multiplicative is exponential. Okay. All right. So a little bit of moving a little bit away from the graphs, it says now that a population of 240 birds increases at a rate of 16% annually. Jamel writes an exponential function of the form, so he wrote an exponential function of this form, f of x equals a times b to the x, to represent the number of birds after x years. Which value should he use for a, and b? All right, so first thing, x represents the number of years. Okay, a, as we just said, was the initial value. So what do you think the initial value would be for this problem? Okay, well, what's the problem even about? It's about birds and the population of birds that's increasing. So the initial value for this would be 240 birds. Okay, and this is going to be the growth rate. Now what I should really specify with this is the growth rate is always written as a decimal. Okay, so right now everything starts at this nice 1, or you can think of it at 100%. Okay, and from 100% you can either increase or you can decrease. So in this question, it's telling you should annotate these words, right? It's increasing. Okay, so we're going to be going above 100. How much above 100? 16%. So this is going to be 116%. Okay, that's what our growth factor is going to be. But we can't write it as 116% because we need to always write it as a decimal. So to convert from 116%, okay, you start off where the decimal is. If you don't see it, it's always at the end here, and you go back 2 spaces. So 1.16 as a decimal is the same thing as 116%. Okay, so our growth rate is going to be 1.16. Okay, and if we wanted to write the equation, it's just simple enough. We just take the general form and you literally only fill in A and B. So y is equal to 240. Okay, now if you have two numbers, they usually put the second one in parentheses, 1.16 raised to the x. See, the only thing that changed was this A and this B. That's all we did, just fill it in. Okay, and then kind of like a review from before, Letitia invests $200 at 5% interest. Okay, so think about this. You're going to the bank, you deposit $200. If you're getting 5% interest, is your money increasing or is it decreasing? All right, so our money would definitely be increasing because we're the ones that's getting interest. So this is going to be an exponential growth, meaning that the B value, the number that's inside the parentheses, has to be greater than 1 or greater than 100%. So if y represents the amount of money after x time periods, which describes the graph of the exponential function relating time and money. All right, so before we even do any of this stuff, okay, don't just forget about all this. Let's just think about what it would be if we were to write our own equation. So if we were to start off by writing our own equation, all right, the only thing that you need to know is your A and your B. A is the initial amount, so how much are you initially putting into the bank? And then the growth rate is 5%, right? But the thing is that it's not just 5, okay? You're gonna start off, right? Everything starts off at 100%. From there, you can either increase or you can decrease, all right? So we are increasing our interest by 5%, so this becomes 105%. And to convert this to a decimal, you just move back 2 spaces. It becomes 1.05. So our B value is going to be 1.05, which means that if we were to write our own equation, this would be 200. Okay, I'm just replacing the A, parentheses, the B, raising into the x. This is literally our equation. And now we just have to go and see which answer matches this. So going through this, let me just erase this x here. All right, it says that the initial value, this is our A value, okay, our initial value is 200. Okay, so let's go through each one. So we know for a fact it's 200. So it could be this. The initial value is 200. Good. The initial value is 500. Bad. You don't need that anymore. And the initial value is 500. That's not true. Okay, the graph increases by a factor of 1.05 per 1 unit of increase in time. The graph increases by a factor of 5 per 1 unit in time. We know that it's going up 5%, but that's the same thing as saying 1.05. That was our B value right there. So this would not be right. It would be the first one. Okay, and then finally, we have this one here. It says a colony contains 1,500 bacteria. The population increases. There's another increases right there. Okay, at a rate of 115% each hour. Okay, so they're telling us what the total increase is. Okay, it's not saying that it's increasing by 10%. They're saying no, it increases at a rate. So they're already giving us the rate, 115% each hour. So x represents the number of hours. There again, x is time, right? Which now this says which function. I should have actually said what function represents the scenario, or like write a function to represent the scenario. So again, we know that this is exponential, right? Anything with percentages there is exponential. So a times b to the x. All right, and before we do that, let's just think about like what each thing means. So what does x represent? This is the number of hours. Okay, that's what it says there. Right, this is the initial amount. So what is our initial amount? And we're going to write that here. A would be 1,500 is the amount that we're starting off with. Our B is the growth rate, okay? And here we have 115%, but we know that we can't leave it as 115%. You need to convert that to a decimal, which is simple enough. You just start at the end and go back 2 spaces, and you get 1.15, all right? And then the last thing is, what does the y equal? So if this tells you the number of hours, the number of bacteria, and how much it's growing by, this tells you the total number of bacteria. Okay, after how long? After X hours. So our final equation then is going to be y equals, okay, remember we're keeping the y's, keeping the x's. The only thing that changes is just a's and b's. 1500 times, okay, 1.15 to the x. This is going to be what our final equation is going to be like. Okay, and that's pretty much all there is to it for exponential growth functions.